Hey guys, today we'll go over 3 Python solutions for the missing number problem on LeetCode. Although there's a clearly optimal solution, which I'll cover at the end, I believe it's always good to think of several different ways we can approach a problem. All the coded solutions shown in this video will be in the description down below. Alright, let's look at the problem statement first. So we're given a list of distinct numbers from 0 to n, where n is the length of the list. And we want to find the number in that range that is not in our given list. So for example, given this list 3, 0, and 1, we know that the numbers we expect are 0, 1, 2, and 3. And we can see that the missing number is 2, which is our output. So for the first solution, we want to use the fact that the indices of a list are simply integers from 0 to n minus 1 in ascending order. This is exactly what we expect the numbers in the given list to be if they were also in ascending order. Therefore, we can sort the list and compare each number with their respective index to check for the missing number. Take note, however, that the indices go up to n minus 1 and not n, so we need to take care of this case at the very end. The basic idea is, first we want to sort the list. Next, we want to iterate through the sorted list and, for each iteration, compare the current number with its index. If they're different, we output the index as the missing number. And finally, if every index matches up with the number, we return the number n. Alright, let's take a look at the coded solution. We first use the sort method to sort the list in place in ascending order. Then we iterate through this sorted list. This enumerate function simply adds a counter starting from 0 along with the list items. We can use this to access both the index and the item in a more Pythonic and elegant fashion for each iteration. We then compare the index with the current number and return the index if the two values are not the same. Finally, if we finish iterating without any trouble, then the missing number must be n, so we return n at the end. The time complexity of this solution is O of n log n, where n is the number of integers in the given list. This is because we're first doing a sort, which takes n log n time, followed by one single iteration through the list, which takes linear time. Since we only care about the most dominating factor in our algorithm, the overall time complexity becomes simply O of n log n. The space complexity is O of 1, or constant space, if we sort the list in place. If we want to avoid modifying the original input, we can return a new sorted list instead, which would mean the space complexity will be O of n. Alright, let's check our solution. Now for the second solution, we'll be making use of the set data structure to improve the time complexity from O of n log n to just O of n, or linear time. This will avoid having to sort the list, which was the main bottleneck for the first solution. So the basic idea is, first, create a set containing all the values of the input list. Second, iterate through the expected numbers from 0 to n. And if an expected number is not in the set, return that number. We're checking each number against a set instead of the original list because checking a list takes O of n operations, while checking a set only takes O of 1 or constant time. So here's the coded solution. First, we simply initiate the set with all the items in the input list. Then we use a for loop to iterate through 0 to n, where n is inclusive, and we return the current number if it is not in the set. As we discussed earlier, the time complexity of this solution is O of n. For the space complexity, since we had to create a set containing all the integers in the input list, the space taken will be proportional to the input, or in other words, it is O of n as well. Alright, let's check our solution. Finally, the third and last solution will be the most optimal in terms of both time and space complexity. Instead of checking numbers one by one, we can simply use some math to figure out the solution. If we compute the sum from 0 to n, we get a sum without the missing number. Let's call this our expected sum. Now if we compute and subtract the sum of the given list with the expected sum, then the result will be the missing number. As a quick example, let's say our expected numbers are a, b, and c. Then we know that the expected sum is a plus b plus c. Now if we're given a list with numbers a and c where b is missing, we can compute its sum, which is a plus c. And in order to find the missing number b, we can simply do a subtraction between the two sums. But how do we compute the expected sum from 0 to n? Luckily, we have a formula for this. The well-known Gauss method or formula states that the sum from 1 to n is simply n times n plus 1 divided by 2. With this information, we can easily find our missing number. Let's quickly run over the basic idea. First, compute the expected sum from 0 to n using Gauss's method. Second, compute the actual sum of the given list. And finally, return the difference between the expected sum and the actual sum. The coded solution is pretty straightforward. One thing to watch out for, however, is we should be using integer division instead of floating point division. This will make sure that the expected sum and return value will be an integer. As for the time and space complexity, since summing up an integer list takes O of n time, this makes the overall time complexity also O of n. In terms of space, we're only storing 2 integer values for all or any inputs, so the space complexity is O of 1 or constant. Alright, let's check our solution. Nice! So yeah, these are 3 different solutions for the missing number problem on LeetCode. I hope you learned something along the way. Please feel free to let me know if you're at all confused with anything in the comments down below. Don't forget to like and subscribe if you enjoyed. Thanks!